He gave the world the most famous equation in history, and it detonated over Hiroshima. Albert Einstein, the genius who unraveled the universe. But his greatest discovery lit the fuse of modern destruction. He fled from Nazism, but helped build the weapon that changed the face of war. He fought for peace, yet his name became a symbol of devastation. How did a pacifist become the father of the atomic bomb? This is the definitive story of a man torn between brilliance and guilt. Einstein's journey from glory to unrest. And it all begins with a formula known around the world. Ulm, March 14th, 1879. Albert Einstein was born, the firstborn son of Hermann and Pauline, non-practicing Jews integrated into a German bourgeoisie, flourishing amidst industrial ferment. Hermann was a merchant who would later become an engineer. Pauline, an amateur pianist with intellectual sensitivity. Although Albert's childhood began in relative calm, the family would soon face economic instability, forcing them to move to Munich, where Hermann would establish a small electricity supply company. A seemingly trivial detail, but one that would, in time, echo in his son's scientific interests. From a very young age, Albert revealed himself to be an introspective, methodical, and profoundly curious child. There was something in the way he observed the world that suggested a mind in constant motion. One of the most emblematic and often romanticized episodes, based on Einstein's own accounts, was the moment when, at 5 years of age, he received a compass as a gift. Watching that needle dance mysteriously, always pointing north, awakened in him a wonder that bordered on the mystical. How could there be an invisible force acting from afar, influencing an object with such precision? It was then that I began to sense that there is something behind things, he would later write, something deeply hidden. At school, however, Albert's brilliance went unrecognized. The educational system of Imperial Germany was rigid, authoritarian, rooted in repetition and military-style discipline. Einstein did not adapt. He rejected dogma, questioned his teachers, and refused to memorize without understanding. The very intelligence that would one day make him famous seemed at that time to be an obstacle. In his own words, "School made me feel as if I were in prison." This discomfort with authority, this tension between free thought and oppressive structures, would become a guiding thread throughout his life, whether in science, politics, or ethics. Yet alongside the rigidity of school, something extraordinary was unfolding. At 12 years of age, Einstein discovered a book that would change his life. Popular Books on Physical Science by Aaron Bernstein. In its pages, he read about hypothetical journeys on beams of light, about paradoxes of time and motion. These were not dogmatic explanations, but invitations to scientific imagination. Soon after, he began exploring infinitesimal calculus on his own, not out of obligation, but from a pure thirst for understanding. His uncle Jakob, an engineer, encouraged him with mathematical challenges, and a family friend, Max Talmud, later known as Talmy, introduced him to philosophy. By the age of 14, Einstein was devouring the works of Kant, Spinoza, and Schopenhauer. And in Baruch Spinoza, the philosopher who saw God in the order of nature, he found a lasting sense of kinship. "I believe in Spinoza's God," he would say decades later, "who reveals himself in the harmony of all that exists, not in a God who concerns himself with the fates and actions of men." But while Einstein's mind continued to expand at home, his situation at school grew worse. At 15 years of age, frustrated by the authoritarianism of his teachers, and watching his family teeter on the brink of bankruptcy, he made a drastic decision. He dropped out of school without a diploma and left for Italy, where his parents had temporarily settled. He had no clear plan, no prospects, only the conviction that he could not remain within a system that stifled his intellectual freedom. It was an act of rebellion, but also of courage. This wandering phase came to an end in Zurich, Switzerland, where he enrolled at the Polytechnic Institute, a prestigious technical school. There he met classmates who would become central figures in his life, such as Marcel Grossmann, who would later assist him in developing general relativity. He also met Mileva Maric, a young Serbian woman, the only woman in his class, with whom he would form an intense and controversial romantic and intellectual relationship. Mileva was brilliant, but faced dual obstacles, being a woman and a foreigner. For a time, they formed an intellectual partnership that, according to some theories, contributed to Einstein's early conceptual developments, although the extent of that collaboration remains a subject of debate among historians. Even with good grades in theoretical subjects, Einstein struggled to find employment after graduation. His irreverent attitude, combined with a lack of political skill, closed doors within the academic world. No university wanted him as an assistant. At one point, he had to give private lessons just to make ends meet. Finally, thanks to the recommendation of a friend's father, he secured a position as a third-class technical examiner at the patent office in Bern. There, amidst reports on mechanical inventions, writing quietly during his breaks, Einstein would find the space and tranquility to nurture his boldest ideas. It was in this seemingly ordinary setting, far from universities, laboratories, and academic halls, that the great turning point began to take shape. In his spare hours, Einstein sketched equations and hypotheses. He returned obsessively to a question that had fascinated him since adolescence. What would an observer see if traveling alongside a beam of light? That image, almost poetic in nature, concealed a radical challenge to the foundations of established physics. For according to classical theory, such a scenario was impossible. But why? This restlessness would, in just a few years, lead him to overturn centuries-old certainties and reshape the very way humanity understands the universe. But for now, he was still just an anonymous clerk, with a mind full of questions. Questions that would soon place him on a collision course with the giants of science. And that, without his knowing, would guide him toward an absolutely extraordinary year. The one history would remember as the Annus Mirabilis. But what exactly would Einstein discover in that year? And why would those discoveries finally make the world listen to his name? 1905. A 26-year-old civil servant walks the streets of Bern, Switzerland, each day on his way to his desk at the patent office. No white lab coat, no laboratory, no team. Just a solitary mind, a notebook, and a restlessness that kept him awake at night. Albert Einstein is on the verge of reshaping the very foundations of science, and it all begins at an ordinary office desk. It is in this year, while still reviewing patent applications for electrical gadgets and timing mechanisms, that Einstein publishes, within a single 12-month span, 4 scientific papers in a little-known journal called Annalen de Physique. Each one, on its own, would have been enough to secure academic immortality. But together, they redefine what we call reality. The first paper addresses the photoelectric effect. Based on an experimentally observed phenomenon, the emission of electrons from certain metals when exposed to light, Einstein proposes something radical: that light behaves not only as a wave, but also as a particle. A shocking idea at the time, it defied the classical view of physics and directly challenged the dominant wave theory. This simple proposal, that light consists of discrete packets of energy, which he called quanta, would give birth to the entire field of quantum mechanics. And years later, it would earn him the Nobel Prize. Not for his ideas about space or time, but for a paper that, at the time, many dismissed as merely curious. In the second paper, Einstein turns his attention to Brownian motion, the random dance of microscopic particles suspended in a fluid. Though it may appear to be a minor phenomenon, he uses it to provide both mathematical and observational evidence for the existence of atoms. At a time when many scientists still regarded atoms as mere hypothetical constructs, Einstein made them undeniable. It was as if he had scientifically unveiled the invisible structure of matter with astonishing precision. But it is the third paper that truly shakes the foundations of physics. In it, Einstein introduces his special theory of relativity. The proposal is as bold as it is elegant. The laws of physics are the same for all observers in uniform motion, and the speed of light in a vacuum is constant for everyone, regardless of the movement of the source or the observer. These seemingly simple premises lead to conclusions that are nothing short of mind-bending. Time and space are not absolute. They bend. Time slows down as one approaches the speed of light. Objects contract. Events that appear simultaneous to one observer may not be to another. In other words, the universe is relative. As if that were not enough, in the fourth paper, Einstein delivers the final flourish, the cherry on top, the formula that would become the very icon of modern physics. E equals mc squared. Energy equals mass multiplied by the square of the speed of light. A simple equation, almost modest in appearance, yet containing a terrifying revelation. Matter can be converted into energy, and there is latent energy within all matter. This meant, in practical terms, that even a small amount of mass holds an enormous amount of energy. Einstein had uncovered nature's hidden code, and unknowingly had opened the door to the destructive power of nuclear fission. These four papers transformed the year 1905 into the Annus Mirabilis, the miraculous year, a term coined by physicists themselves to express the earth-shaking impact of these ideas. But the world did not respond immediately. The scientific community, for the most part, did not yet grasp the full scope of those publications. Einstein, still without an academic position, continued his routine as a civil servant. But the seed had been planted, and in the years to come, it would grow with unstoppable force. Little by little, the brilliance of the once unknown young man began to be noticed. Scientists like Max Planck, a central figure in German physics, recognized the depth of his ideas and began to champion them. Planck even risked his own reputation by defending the young Einstein's proposals before more conservative colleagues. With that, doors slowly began to open. In 1909, Einstein finally secured an academic position at the University of Zurich. Within a few years, he was invited to teach in Prague, later returning to Zurich and ultimately taking up a post in Berlin at the prestigious Kaiser Wilhelm Institute, where he would become the youngest member of the Prussian Academy of Sciences. This was the turning point. Einstein transitioned from an obscure clerk to a rising star in the European scientific firmament. But true recognition was still to come. After all, while his theories were mathematically sound, they still lacked definitive empirical proof. What was missing was someone who would look up to the sky, quite literally, and witness the universe bending under Einstein's logic. That confirmation would come in 1919, with a solar eclipse observed by British astronomers in West Africa. But that story, with its political twists and unexpected transformations, deserves a chapter of its own. Because with scientific vindication came something entirely new: fame. And with fame, the collision between genius and the world. Einstein would become more than a scientist. He would become a symbol. And symbols, as he would soon learn, no longer belong to themselves. May of 1919. The world was still healing from the open wounds left by the First World War when a group of British astronomers, led by Arthur Eddington, set sail for the island of Principe off the coast of Africa with a singular objective: to observe a total solar eclipse. During the brief moments when the sun's light would be blocked by the moon, they would have the chance to test a groundbreaking prediction of Einstein's new theory: the idea that gravity is not an invisible force acting at a distance, as Newton had proposed, but rather the curvature of space-time caused by mass. If the light of distant stars were bent as it passed near the sun, just as Einstein had predicted, it would serve as definitive validation of general relativity. And it did. When the results were announced in November of that same year, newspapers across the globe printed headlines that had once seemed unimaginable. Newton's ideas surpassed. New theory of the universe confirmed. A genius emerges. In an instant, Albert Einstein went from being a relatively known physicist to an international celebrity. The world, still traumatized by global conflict, seemed desperately hungry for figures of reconciliation. And there stood a German scientist being celebrated by the British, their former wartime enemies, based on an experiment conducted in an African colony. The symbolism was irresistible. Einstein became not only the face of modern science, but a kind of ambassador of the human spirit. But fame comes at a price, especially for those who challenge the status quo. Einstein, a devout pacifist, refused to remain silent about the direction Germany was taking in the aftermath of the war. He openly criticized militarism, rampant nationalism, and the rising tide of anti-Semitism. "My pacifism is not merely an intellectual conviction. It is a demand of the heart," he wrote in a public letter. That stance made him a target. Conservative newspapers attacked him for his political views, for his Jewish heritage, and for a brand of science they labeled as subversive. A storm was beginning to gather around him. Meanwhile, within the scientific community, his ideas were also facing new resistance. Quantum physics, which had emerged in part from his own work on the photoelectric effect, was taking unexpected directions. Thinkers like Niels Bohr, Werner Heisenberg, and Max Born were proposing a radical new vision of the universe, one in which uncertainty and chance were not signs of incomplete knowledge, but fundamental features of reality itself. Einstein, however, rejected that notion. To him, the universe had to be governed by deterministic laws. "God does not play dice with the universe," he famously insisted. This stance would put him on a collision course with the rising generation of physicists. And though still revered, Einstein was beginning to be seen as a barrier to the very science he had helped bring into existence. On a personal level, Einstein's life was marked by turbulence. His marriage to Mileva Maric deteriorated rapidly. What had begun as an intellectual partnership gave way to a relationship defined by emotional distance and growing resentment. In 1919, they officially divorced. But not before Einstein promised that, should he ever receive the Nobel Prize, the full monetary award would be given to her and their children. That same year, he married Elsa, his cousin, in search of a more stable domestic life. But Einstein would never truly be a man of the home. His world was one of ideas, lectures, travel, and protest. By the 1920s, Einstein had become an almost mythic figure. He was welcomed by crowds in New York, gave lectures to packed halls in Tokyo, met with Gandhi in India, and exchanged letters with Sigmund Freud on the roots of war. His image, unkempt hair, rumpled clothes, dreamy eyes, became a pop icon, appearing in caricatures, magazines, and posters. But at the same time, in Germany, the winds of intolerance were growing stronger. Ultranationalist movements began accusing him of betraying the fatherland. His name appeared on political hit lists. In 1922, his friend and colleague Walter Rathenau, Germany's foreign minister and also Jewish, was assassinated by extremists. From that moment on, Einstein began traveling with an armed bodyguard. The situation worsened with the rise of Nazism. In 1933, Hitler came to power, and the first measures against Jews and political opponents were swift. Universities were cleansed, books were burned, scientists were exiled or silenced. Einstein, who at that moment was in the United States giving lectures, made a definitive decision. He would not return. "As long as I have any choice, I shall never again set foot on German soil," he declared. He renounced his German citizenship, severed ties with the country's academic institutions, and became an American citizen in 1940. His exile, however, was not merely physical. Einstein realized that the world he had helped explain through equations was now heading toward the abyss. In 1939, under pressure from colleagues like Leo Szilard and warned of Nazi Germany's nuclear ambitions, Einstein did something that would haunt him for the rest of his life. He signed a letter to President Franklin Roosevelt, urging the United States to begin research into atomic weapons. Though the letter had been written by Szilard, it bore the moral weight of Einstein's name. It was taken seriously and played a role in the birth of the Manhattan Project, the top-secret American program that would ultimately lead to the atomic bombings of Hiroshima and Nagasaki. Einstein never took part directly in the project. He never set foot in Los Alamos, never worked alongside Oppenheimer. But when the Japanese cities were destroyed in August of 1945, the world did not look only at the military or the government scientists. Many saw, above all, the face of the man who had written E equals mc squared. The same mind that had shown how to convert mass into energy was now linked unavoidably to atomic horror. He, who had long dreamed of peace, had become unwillingly one of the fathers of mass destruction. From that moment on, Einstein's life entered a new phase, no longer a quest to understand the universe, but a mission to save humanity from itself. He would spend the rest of his days as an activist, warning against the dangers of nuclear proliferation, advocating for disarmament, and calling for a global federation that might prevent humanity from repeating its gravest mistakes. But the question lingered: was the world truly willing to listen to him? 1955. In a modest home in the town of Princeton, New Jersey, an elderly man with white hair and a calm expression lies resting in bed. Albert Einstein, at 76 years of age, refuses a surgery that might have extended his life. "I want to go when I want. It is tasteless to prolong life artificially," he is said to have told his doctors. A few days later, on April 18th, his brain, the same one that had defied the pillars of reality, ceased its activity. But the world had already changed, and his shadow still lingered over it. Einstein died troubled, not about his reputation, but about the future of humanity. In the years leading up to his death, his public image became increasingly tied to political activism and the pursuit of a more just and secure world. He spoke out against racial segregation in the United States, refused offers for political office, and used his global fame to warn of the existential risks posed by nuclear war. In 1955, just weeks before his passing, he became one of the first signatories of the Russell-Einstein Manifesto, an urgent appeal for the world's powers to abandon nuclear weapons and seek diplomatic solutions to global conflict. "Remember your humanity and forget the rest," the text declared. It is this ethical dimension that makes Einstein more than a scientist. He was also a moral symbol, albeit an imperfect one. Throughout his life, he was torn between his desire to understand the universe and his anguish over the destructive use of that knowledge. And perhaps it is this paradox, the man who unlocked the secrets of the cosmos and then saw those secrets turn toward destruction, that makes Einstein such an enduringly unsettling figure. But his legacy reaches far beyond the tragedies of the 20th century. Modern physics is unimaginable without his contributions. General relativity, confirmed over the decades with ever greater precision, forms the basis for everything from the GPS in our smartphones to the study of black holes and gravitational waves. In 2015, exactly 100 years after he first formulated it, scientists at the LIGO Observatory detected for the first time the ripples in space-time he had predicted. It was as if the universe, a century later, had once again whispered back, Einstein was right. In quantum mechanics, although Einstein disagreed with its probabilistic direction, his intellectual provocations helped sharpen the very foundations of the theory. Modern experiments, such as Bell tests, which demonstrate non-locality and quantum entanglement, were in part motivated by Einstein's own arguments against what he saw as the theory's incompleteness. Thus, even in criticism, he nourished the soil of science. And then there is Einstein the philosopher, Einstein the thinker. In times of polarization and hatred, his voice still echoes with rare clarity. Nationalism is an infantile disease. It is the measles of mankind. The world is a dangerous place, not because of those who do evil, but because of those who look on and do nothing. Phrases like these continue to circulate, not as empty slogans, but as lucid warnings from a man who had witnessed the extremes of the 20th century, from Enlightenment hope to industrialized barbarism. Einstein also left us a singular example of intellectual independence. In a time when knowledge was tightly controlled by institutions and hierarchies, he proved that true genius can flourish on the margins, that curiosity, imagination, and the courage to think freely remain transformative forces. Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world. That sentence, so often quoted, captures not only his scientific spirit, but also his broader posture toward life. Perhaps that is why Einstein remains so present in contemporary culture. He is not remembered solely in equations or laboratory results. He appears on street murals, t-shirts, cartoons. A pop icon, yes, but one who stands for something rare, the fusion of reason and compassion, of brilliance and humanity. His image reminds us that science is not a cold abstraction, but a profoundly human endeavor, filled with doubts, errors, discoveries, and moral dilemmas. And even today, we live with the echoes of his choices. We inhabit a world still haunted by the specter of nuclear destruction, yet one that also benefits daily from technologies he helped make possible. Satellites, computers, energy, space exploration. All of it carries the DNA of the scientific revolution that Einstein set in motion. It is as if we are forever standing before a delicate scale. On one side, the potential for creation. On the other, the risk of destruction. And at the center stands Einstein, reminding us that knowledge without responsibility is a double-edged sword. Near the end of his life, when asked how he wished to be remembered, Einstein answered with humility, "I want to be remembered as someone who found joy in trying to understand something." And indeed, it is that pursuit of understanding, of the cosmos, of life, of the human being, that pulses through every line of his equations, every word of his letters, every thought he left behind. Today, every time we use a GPS, gaze at the night sky, or debate the boundaries of artificial intelligence, we are in some way continuing a dialogue with the legacy of that young man who once wondered what it would be like to ride alongside a beam of light. Einstein gave us more than answers. He taught us how to ask the right questions. And perhaps that is why, even after his death, he continues to haunt us, not with fear, but with the weight of a truth. That reason must always walk hand in hand with humanity, because he did not merely open Pandora's box. He warned us about what might escape from within it, and what we choose to do with that warning is a decision we still have to make.